Everyone, it's Mr. Rainsberg. I wanted to make a video that goes over the formulas for ellipses, the horizontal and vertical ellipse formulas. The main reason why is because the formulas have a lot of variables in them, but ellipses are very visual. And if you can learn the visual tricks to these formulas, it'll make it a little bit easier to graph, actually make it faster to graph. And so we have our equations, but I'm not going to focus on those equations yet because the equations, I look at them and they're pretty much the same. You have an x minus h squared here, you have an x minus h squared here, a y minus k squared, a y minus k squared equals 1. So there's some similarities. The difference is right here. Well, this is a squared in the bottom. This is b squared in the bottom. This is b squared over here in the second fraction, but over here it's a squared. And so the question goes, well, how do you know which one's a or which one's b? And that's not where you should start. That's not the question you should ask. So we're not going to start with these formulas for the equations. We're going to start with the center and then the vertices, then the co-vertices, then the foci. So we should focus here. And then that will help us up here to see what's going on. For both horizontal and vertical, the center is HK. So it's going to give us the center whenever it gives us the equation on it. And since the equation has x minus h and y minus k for both of them, you know, it's always like the opposite. And so if I have x plus 2, then h is negative 2. If I have y minus 3, then k is positive 3. And the same over here for vertical. So it's kind of the opposite of the parentheses. We're kind of used to that by now in pre-calculus. So when we go through, let's look at the vertices. So the vertices both have that h and that k on it. So I can take a look at them. I have my h and my k, I have my h and my k, and notice I still have my h and my k. I still have my h and my k. The difference between the vertical and the horizontal ellipse formulas is what are you adding the a value to? I mean, it says plus or minus a. It says plus or minus a. For horizontal, you're adding and subtracting a to the h value. For vertical, you're adding and subtracting a to the k value. But when I look at this, I can think of a definition. And this definition should always help us with graphing. The definition is that vertices are a units from the center. That is a standard definition. That will always be the way it is. Even when we go into hyperbolas, same concept. Vertices are always a units from the center. Now, horizontal versus ellipse, that's the question. And we'll get to that. Like I said, we're going to get to that at the end. No, let's go to co-vertices. So let's look at the same idea. If I'm dealing with co-vertices, I still have an h and a k. I still have my h and a k. So what's the difference? Well, it looks like in this case, I'm adding and subtracting b this time. For the horizontal, I'm adding and subtracting b to the k value. For the vertical, to the h value. But that's not the concept. The concept is that co-vertices are b units from the center. And that's always going to be true on it. And then we go down to foci. It's a lot of formulas, but we're kind of learning, well, they're just one letter. Vertices are the letter A. Co-vertices are the letter B. So what are foci? Foci are based off of the letter C. Because notice I'm adding and subtracting C to either H or K for the foci formula. And so foci are C units from the center. There's more patterns to it we're going to get to in a minute. Now, what is C? Well, that's where you have this formula here, c squared equals a squared minus b squared on it. So you're going to have to use that formula to find c on it. But I'm going to kind of look at one other thing. So let's see, we kind of see that our formulas all involve an h and a k. I highlighted those. They involve a plus or minus c for the foci to either h or k, plus or minus b for the covertices to either h or k, plus minus a to the vertices. So what else can we see from this before we go to the equation? Well, if I erase what I have so far and kind of focus on one more thing, because there's a lot there, but so far I just need to know what my center is, and I need to know three things. A are for vertices, B are for covertices, C are for foci. Now, one other thing I'm going to draw attention to is right here. Your vertices for horizontal are adding, subtracting A to H. And notice your foci are also adding, subtracting with H. For vertical, it's adding, subtracting for K for vertices and for foci. So vertices and foci are on the same, and I'm going to put it in parentheses, axes, quotes there. They're on the same axes. We call it the major axes. We call covertices the minor axes on it. And so we take a look. I guess I still have yet to look at the equations. I'm just focusing on the visual aspect. Here's my center, H comma K. Now this is a horizontal ellipse. Horizontal ellipses are stretched out more horizontally. They have more eccentricity horizontally than they do vertically. And so when I look at that, that's my center. And when I go through and I have my formulas for it, we got blue, I'm going to see these are my vertices. These are my vertices. All I'm doing is I'm staying on that same K value. It's on the same height as that. So my K value stays the same for both of these. The difference is I am moving to the right A units. That's why this formula is H plus A. I'm moving to the left A units. That's why this is H minus A. I have that up here for covertices. My covertices formula, notice, it's going to have just an up and down change. It does not move left or right on this. And so the H values are going to stay exactly the same. So this is H and H for my X. But for covertices, you're going up B, so that's going to be K plus B, and you're going down B, so that's K minus B on this one. So these are where these formulas go through and where they come from. And again, notice foci are on the same axes as your vertices. So here I'm subtracting C, and here I'm adding C. So this would be H plus C comma K, and this would be H minus C comma K. So I can see all I'm doing is finding the center. I'm moving left, right, up, down, and again, left, right again for a different value. And that's it. I just need to notice those numbers. Now you can see this is a horizontal ellipse because it's stretched out more horizontally on it. Let me put this minus sign here. And so when we go through, I just have to find my center. I have to find, because that gives me my HK. I gotta find what's A. I gotta find what's B. I have to find what's C. And then I either move left, right, up, down, based off of which ellipse it is. A is always attached to the vertices. B is always attached to the covertices. C is always attached to the foci. So that's a focus, and that's a focus. So that's a horizontal. Now, I'm not going to go look at the formulas above, but let's take the same idea. My center is still HK, so that's good. But now, this is a vertical ellipse. So notice it's stretched out more vertically. I mean, this is longer than the left to right stretch. It has more eccentricity. So that's the vertical ellipse. The definition is the same. This distance from the center to that far vertex is A units. And I'm staying the same. I'm not moving left or right at all. So the H value stays the same, but I'm going up and down. So K is adding, and I'm subtracting to K because I'm moving up and down to plot these vertices on it. So that's why the A value gets added and subtracted to K. What about with your co-vertices? Notice co-vertices here, I'm moving left and right. So that's going to affect the H value, that X coordinate. So I'm going to add, subtract B to H, and that gives me my co-vertices. That's the same definition as it was for horizontal. Foci are located on the same axes as your vertices. And notice you're just going up and down. So you're affecting your vertical, you're affecting the K value. So that's why this is HK plus C and this is HK minus C. There's a visual pattern to these formulas to understand. And that's really center vertices foci, is you are counting up, down, left, right, depending on which ellipse you have. And now I'm going to talk to you about how do I know which ellipse you have? Well, if you're moving a further distance here for your vertices, because it's stretched out more for horizontal, or here for vertical, you're moving a further distance there because it's stretched out more. A is always going to be for an ellipse. This is only for ellipse. A is the larger number. But the formula doesn't deal with A, it deals with A squared. So A squared is the larger number. Whichever denominator has the larger number in it tells you whether it's vertical or horizontal. And the reason why is if my larger number is under the Y, I'm stretching the graph more vertically. And if my large number is under the X, I'm stretching the graph more horizontally on it. This is just meant to show you the visual pattern to it. We're still going to go through the notes on it, but hopefully you found this helpful as kind of an introduction on you really are looking for three values, A, B, C. And you're looking for three definitions for them. A is the distance from the center to the vertices. B is the distance from the center to the co-vertices. And C is the distance from the center to the foci. And that vertices and foci are on the same line, the same axes. Those three definitions make graphing ellipses a visual pattern, not a formula pattern. If you can't understand the visual pattern though, that's okay, because you have the formulas. You can plug them in and get the same answers, whether you're using this or you're using a concept. As always, if you have any questions, please reach out and ask.